got it, damn, got it.
Hey guys, welcome back to week 5 of distance learning. This week we're going to be learning about multi-step word problems. So we're going to take all the different operations that we already know and apply them to word problems. So just as a FYI, Zoom calls this week, again, they're the same time every week from now on. They're 12 p.m. every Tuesday and Thursday. So just make sure to click the link in the PowerPoint and the overview document in order to access them. So again, you can log in if you need help, if you just want to check in, if you want to say hi, if you want to share any news about yourself, anything like that. And just a little note that I do miss all of you very much. So we're going to start with some vocabulary. All of these words we've seen in class before. And so not only do they come up in word problems, but sometimes we have to infer them. So hopefully you've learned about inferencing in your reading classes this year. So inferencing, meaning we're taking the context of the word problem and seeing which operation makes sense in this case. So the word difference, we know often means subtraction. The word sum means addition. The word product implies multiplication. And the word quotient implies division. So these are words that we've constantly seen in our math class. Then there are words that are a little more ambiguous, meaning that they could go either way. So the word left, when you talk about something left over, this typically means something has decreased, right? If you eat a piece of pie, that means you have leftovers. It is less than the original pie. So this usually means subtraction or division. We know that division is really just repeated subtraction, so that makes sense why it's left over. When we think about the word total, it's kind of the opposite of left. So we're totaling something. So this usually means an increase. So this comes in the form of addition or multiplication. Again, we know that repeated addition is multiplication. So that's why both of those terms could be used in the word total. So again, even though the words are often associated with operations in math, we want to make sure we're reading the problem and understanding it before we try solve it. So the next slide indicates context matters. Again, when we talk about context, that means reading the problem and understanding it before we try and solve. So the word each and the word times usually imply multiplication or division. So we're going to go through a few examples and see how the word each first. The word each can imply either multiplication or division. Then we're going to talk about the word times. So the first two relate to the word each. So the first question says each pen costs $3 and you buy 4 pens. So if each of them are $3, that means you have $3 for one pen, $3 for another pen, $3 for another, and $3 for the 4th pen. This is repeated addition, or like what we call multiplication. So 3 times 4 equals $12. So this was a multiplication question. So if we look at the next question, it says there are 18 cookies and each person, again, this is the word each person can get 3 cookies. How many people will get cookies? So again, we have the total already. We have the number 18. And we are splitting it up among a certain number of people. We don't know how many yet. But because we're splitting it up, this problem is really a division problem. So we're splitting them up into groups of 3. So we're basically saying how many 3s can you fit into 18? So 18 divided by 3 equals 6. So you can feed 6 people. And remember, we can double check our division by using multiplication. If there's 6 people and each of them get 3 cookies, that means 6 times 3 equals 18 cookies. So you can see how the word each can be used for multiplication or division. So let's take a look at our times questions, which again, most of the time when we hear the word times, we think about multiplication, but it can be used for either. So the first question says, John has 3 pairs of shoes. Joe has 5 times as many. How many pairs of shoes does Joe have? So again, we know that John has 3 pairs and Joe has 5 times as many. So just like the wording says, he has 5 times as many. So 3 times 5 equals 15 pairs of shoes that Joe has. So again, this was a multiplication question. The next question says, the tree in Susie's yard is 36 feet tall. So if we kind of draw a tree here. It's a very odd looking tree, but so it's 36 feet tall. The tree is 9 times as tall as Susie. So Susie is down here, and it's 9 times as tall as her. So we can do this a few different ways, but really this is a division problem. We're trying to see how many Susies fit into this 36. So we know that there are going to be 9 Susies that fit. So we're going to do 36 divided by 9. And that means that Susie is 4 feet tall. So again, if she was 4 feet and you multiply it by 9, you end up getting 36. So our last problem is a multi-step word problem, and it's an example, and it will be similar to the IXL questions you see. So if you have $114 to spend at the mall, you end up buying 3 hats. Each hat costs $12, and 2 pretzels. Each pretzel is $4. How much money do you have left over? So let's take a second to decompress this problem. So we start with the money that we have. We have, again, it says $114. Then we spend a bunch of money on hats, on pretzels. So again, we're spending money at the mall. So that means that we are going to subtract. So again, we're spending money. So we're going to subtract. And that will give us our leftover amount. So we're trying to find out how much it is that we're actually spending to figure out what's left over. Again, this is multi-step. So first we have to figure out how much we spent. So we again bought 3 hats, and each of them was $12. Again, just like the problem from the previous slide, if each of them cost $12, that's repeated addition, 12 plus 12 plus 12, which is the same thing as multiplication. So our hats cost us 3 times 12, which is $36. So then we bought 2 pretzels, each for $4. Again, if we have 2 pretzels, each are 4, so 4 plus 4, that's 8, or 4 times 2, which is also 8. So again, we have $4 for each pretzel, and we bought 2 of them. So we spent $8. So how much total did we spend? Now we have to add what we spent. So we spent $36 and $8. If we add these together, we get $44. So we spent $44 at the mall. So that's not what we're being asked though, right? It says how much do we have left over? We know we had 114, we spent 44, so we have to subtract to find the leftover. So we're going to take 114 and subtract 44. So I know 4 minus 4 is 0. And then I have 11 minus 4, because again, 1 minus 4 wouldn't work. So 11 minus 4 ends up being 70. So we have $70 left over. So again, this is a multi-step problem. First, we had to figure out what operation we were doing. Again, to find the leftover, we had to use subtraction. So we used subtraction. We had to use multiplication to find out how much we spent. And we had to use addition to find out how much the partial products were of how much we spent. So we used 3 of our operations that we know, all in one problem.
Damn, got it. Damn, got it.